Welcome to EDU World Space.
In this exercise, we're going to use the concepts of acceleration and variation of velocity. So let's briefly remind how to relate them both. So basically, remember that the variation of velocity, which is equal to the velocity of a particle in time t minus the velocity of a particle at time t0, is equal to the integral of the acceleration of the particle times dt from t0 to t. So now we are able to dive into our exercise. In this exercise, we have a motor M that's connected to block A by a rope, and the force that the motor exerts on the rope is given by this graph. And the force is given in pound force as a function of time that is given in seconds. And with this information, our goal is to find what is the speed v of block A after a time t equals 2.5 seconds has passed. In order to do that, first we need to find an expression for the force that the motor exerts on the rope as a function of time. Notice that the graph is just a line. It begins at the origin. So the force is equal to 100 pound force per second times t. Now notice that this fits the graph, since for t equals 0, the force is 0 as it should be, and for t equals 2.5, the force is 250 as it should be, and 2 points define a line, so everything is fine here. So this is the force F as a function of time. Okay, also remember that 1 pound force is equal to 32.2 pounds feet per second squared. So in reality, F is equal to 3,220 pound times feet per second to the third times c. This is the expression of the force. And now let's draw a free body diagram on the block. So this is block A. We can separate the movement of block A into two parts. So first, when block A is still on the ground, there are the following forces that act on the block. There's the tension acting upwards. There's a normal force that the ground exerts on the block acting upwards, and also the gravitational force acting downwards. Okay, and this results in the equation T plus N minus mg is equal to 0. And notice that as the force on the string increases, this is equal to ma, I'm sorry for that. But A, when the block is on the ground, is equal to 0, because the block stays on the ground. So we can say that this equation here is equal to 0. Now notice that as the force on the rope increases, the tension increases, and the normal force decreases. Okay, until the normal force reaches 0. When the normal force reaches 0, the block starts to be lifted up. So that happens when the tension on the string is equal to mg. Now notice that the tension on the string is equal to the force that the motor exerts on the string. So the tension is 3,220 pounds feet per second cubed times T, and this is equal to the mass, which is 100 pounds. Actually 200 pounds, I'm sorry. That's the mass of the block. Okay, so let me just write it here. The mass of the block is 200 pounds times G. And G is 32.2 feet per square second. So obtain that T is equal to 2 seconds. So this is the time it takes for the block to start being lifted up. Okay, so for 2 seconds, the block is on the ground and not lifted up. So basically, after that, we have that the forces on the block are just the tension and the gravitational force. So we have that T minus mg is equal to the mass of the block times the acceleration, meaning that the acceleration is T divided by m minus g. Now T, as I said, is 3,220. M is 100 pounds, so we have this times the time t minus g, which is 32.2 feet per square second. And I'm sorry, again, I wrote the mass as it was 100 pounds when it's actually 200 pounds. So A is equal to 16.1 feet per second cubed T minus 32.2 feet per second squared. And the variation in speed is equal to the integral from t0, which is 2 seconds, to the final t, which is 2.5 seconds, of A, that's 16.1 times t minus 32.2 times dt. The variation of the speed is the speed itself minus the initial speed, which is 0, and this is equal to 16.1 t minus t0, so that's, sorry, the t squared. Let me write it like this. 16.1 t squared over 2 from 2 to 2.5 minus 32.2 t from 2 to 2.5. So V is equal to 16.1 divided by 2, 2.5 squared minus 2 squared minus 32.2, 2.5 minus 2, and this is equal to 2.01 feet per second. So this is the speed of the block after a time of 2.5 seconds, which concludes our exercise.